Hello. Today we are going to discuss about public key infrastructure. The contents what we are going to look is what is public key infrastructure, purpose of public key infrastructure, what is PKIX and its elements, PKIX management functions, PKIX management protocols, working of PKI, and real-time example of PKI. What is PKI? Public key infrastructure is the set of software, hardware, people, policies, and procedures that are needed to create, manage, store, distribute, and revoke the digital certificate based on asymmetric cryptography. We know that in asymmetric cryptography, there is the requirement of two types of keys, that is, public key and the private key. Public key is the one which is known to the connected devices. So this public key cannot be shared directly. So this is shared through the digital certificates. So the public key infrastructure is the one which has the uh, certificate authority, which will give the digital certificate in which the public key will be carried. What is the purpose of public key infrastructure? The principal objective of developing public key infrastructure is to enable secure, convenient, and efficient acquisition of public keys. The main purpose of PKI is to share the public key through the digital certificates. What is PKIX? The public key infrastructure based on X.509 is called as PKIX. Here you can see the infrastructure or the architecture of the PKIX. It has the following elements. End entity. End entities are nothing but the users who want to connect or who want to share the public key between them. So if at all a user want to share the public key, he will give his information and the device's information to the certificate authority, and then the user's identity will be verified and the certificate is issued to the user. So this entity can be server or any other devices. So the next is certification authority. So it is the main element which is focusing on creation, storing of creating, managing, storing of the digital certificate to the user. Next, registration authority. This is the optional element of the architecture where whenever the user first registers to the registration authority, he will give the information such as his identity to the registration authority. This information can be then sent to the certification authority for the issuing of the certificate. Next, CRL issuer, that means certificate revoke list issuer. This comes into picture when there is when the public key or the private key is compromised. So then we have to revoke the certificate that has been issued to the user. So that case, this element of the architecture comes into picture. Then repository. So it is a kind of database where we store and manage the certificate that is being issued by the certification authority. So we can study the elements of the architecture in detail. So end entity is a generic term which is used to denote the end systems such as servers, routers, etc. Next, certificate authority. As I already mentioned, the issuer of the certificates and certificate revocation list. It may also support a variety of administrative functions, although these are often delegated to one or more registration authorities. So next is registration authority. It is an optional component that can assume a number of administrative functions. The RA is often associated with an entity registration process but can assist in a number of other areas as well. Then CRL issuer, an optional component again that a CA can delegate to publish CRL. So as I already told, it comes into picture when the private key is compromised. Next, repository, a generic term used to denote any method for storing the certificates. So it is a kind of database which is used to store the certificates that has been issued by the certification authority. Next, the functions performed by PKX are registration, initialization, certification, key pair recovery, key pair update, revocation request, cross certification. So registration. So in any aspect, registration is the first process where we give the information and get it stored. So here also registration begins the process of enrolling in a PKI. User first makes itself known to CA. Prior to that, CA issuing a certificate to the user. That means a user will make himself known to the certification authority before the certification authority gives the certificate, digital certificate, to that user. So registration usually involves some offline or online procedure for mutual authentication. Next is initialization. Before a client system can operate securely, it is necessary to install a key materials that have appropriate relationship with key stored elsewhere in the infrastructure. For example, client needs to be securely initialized with the public key and other assured information of the trusted CAs. Next is certification. This is the process in which CA issues the certificate for user's public key, returns that certificate to the user's client system, or posts or saves this certificate in the repository. So this is the main function where the certificate, digital certificate, is issued and stored in the certificate repository. Next is key pair recovery. Key pairs can be used to support digital signature creation and verification. So, this function is to verify the digital certificate that has been generated by the certification authority. Key pair update. All the key pairs need to be updated regularly. So, in case if the digital certificate is revoked, in case of private key, when it is compromised, the digital certification is revoked, right? So that time all the key pairs has to be updated in the repository. Revocation request. So this is the request of revocation of the digital certificates. So when the private key of the system is compromised or the digital certificate itself is compromised, then that certificate has to be revoked back from the user. So that time revocation request function comes into picture. Then cross certification. So consider two users want to exchange their public keys and they will come across two certification authorities. So suppose A is the certification authority, x1 is the one certification authority, and x2 is one more certification authority. So the user A will take the certificate from x1. Similarly, user B will take the certification from x2, and they will exchange their certificates. But now, user A can only read the uh, certificate given by the B, digital certificate given by the B, but it cannot verify it. Why? Because the certification authorities have does not have the connection. So to make that, first we have to bring the connection between x1 and x2. So for that, uh, we have to approach a certification authority, then we have to exchange their public keys. That time only a user A can verify the certificate given by the uh, user B. So that is nothing but cross certification. That means the certification authorities also have to be verified. Next, then PKI management protocols. There are two protocols: RFC 2510, which defines the certificate management protocol, which can request, revoke, suspend, and resume certificate. Next one is RFC 2797, which defines the certificate management messages over CMS. CMS can encrypt, decrypt, sign, and verify, compress, and decompress the CMS documents. Next, how the infrastructure actually works. Now, if the user wants to get an access to the information that is in the web, so first what he does is, first he will put his information to the registration authority. Then the registration authority will confirm the user's identity and it will do the registration. Next, after the registration, the user will get the receive ID and password. Next, To get to download the registration certification which is given by the certification authority, user has to install some of the software and generate the key pairs. Next, the user now will request for the certification authority for the certificate. Then a certification authority will issue the certificate, and this certificate will be sent to the verification. Later, at the end, user can download the certificate. This is how the public key infrastructure works. So example, we can see a user who is having the access to both public key and private key give the information to the registration authority. On the successful OK of registration authority, this information is sent to the certification authority. The certification authority will issue the certificate, and this certificate will be verified, and uh, and it is shared to the next connected user. So this is how the real time example of PKI works. Thank you.